Hello everyone. So we are doing previous year gate questions from the subject signal and system. So this is our next topic, which is Fourier series and Fourier transforms. This is a very important topic when it comes to signals and system. And in this topic, basically we deal from conversions from time domain to frequency domain. So this is what is happening in this particular topic, right? Fourier series is a different topic. Fourier transform is a different topic if it say in theory, but in numericals, I am taking both of them together, right? So these are two basic tables for which we can study these transforms, which is from time domain to frequency domain xt to x of f, right? So this table is comes very handy when we are doing questions or numericals. So this is the table which you should know, right, when you are going to your examination center. Now, we won't be focusing on the theory part much because in these series we are focusing on the previous year gate questions. So these tables and the properties and everything we can always learn with the theory when we are solving the theory. But now solving the numericals. So this is your first question. Let x1t is equals to u of t plus 1.5 minus u of t of 1 minus t minus 1.5 and x2t is shown. So x22 is there and you have to for yt is equals to x1t convolution x2t, the integration from minus infinite to infinite yt dt is, and you have to find out this. Now in this question, there is nowhere written that you have to find out the Fourier transform or you have to find out any Fourier series coefficient or XYZ. So how will you know that you have to solve this type of question by using Fourier transforms? Very easy, very easy to understand that whenever you see this function in time domain, what is this happening? Convolution. So convolution is a lengthy and time-taking process. Whenever you are going through the traditional method and finding out the convolution of these two, x1 to n, x1t and x2t, so this gonna take a lot of time, right? So instead of doing the convolution part, what we do, what's easy and what makes our calculation fast and what makes our solution faster, so that is by changing time domain signal to frequency domain signal, and that can be easily done by Fourier transforms, right? We know that in time domain when the convolution is there, in frequency domain it becomes multiplication operator, right? So convolution in time domain is multiplication in frequency domain and vice versa. Convolution in frequency domain is multiplication in time domain. So to make this question very easy, what we can do is convert this function x1t into its frequency domain component, similarly x2t into its frequency domain, and we can easily say that y omega, which is convolution of x1t and x2t in time domain, will be equal to x1 omega into x2 omega. It's that easy. Now, what is this? This is minus infinite to infinite yt dt. It is nothing but y of 0. We will see how that it is y of 0. So if you want to find out area under the curve whenever you are seeing in time domain, that will be equal to y of 0 component in frequency domain, right? Let's just start solving this question so that we know that how to solve this question in frequency domain. So x1t is equals to u of t plus 1.5 minus u of t minus 1.5. How to plot it? It is a ut function. Firstly, starting from minus 1.5 and similar function is subtracted at plus 1.5. So this is your x1t. Now x1t is a rectangular function with a time period of 3, right? So rectangular function into its frequency domain is equals to sampling function or sinc function. So how we write rect function t by tau, tau is time period only. In frequency domain, by using Fourier transform, it will become tau sampling tau by 2 into omega, or it is same as sinc tau by 2 into omega. So this function is equals to, this is how I can write this function, t by 3. So x1t, that is equals to rectangular function t by 3 will be equal to tau, that is equals to 3, sampling 3 by 2 into omega, so that will be equal to 3 sampling 1.5 omega. So this is x1 omega. Similarly, we can easily find out the Fourier transform of this particular function x2t. How? So x2t is given as, the magnitudes are also given. So this is x2t in time domain. So I have to convert this into frequency domain. So these are impulses only at -3, -1, this is 1 and this is 2. So this is impulse function. So impulse Fourier transform is equals to 1 only. But whenever we are shifting it, so shifting property allows you to multiply the function with e raised to power the shift into j omega. So if I am saying this is what? T plus 3. So its Fourier transform will become e raised to power 3 j omega, and similarly this function is delta t minus 2, so this will become e raised to power minus 2 of j omega. Easy. And this is in the center, it is again rectangular function, so it is rect t by 2 because its time period is 2. So now I can write complete x2 omega in frequency domain, so that will become e raised to power 3j omega plus, if I convert it into its frequency domain, so that will be 2 sampling omega, 2 by 2 will become 2. So 2 sampling omega plus 2 e raised to power minus 2, 2 because it is having magnitude of 2. So 2, 2 j omega. Now, as we know that, so convolution in time domain is nothing but multiplication in frequency domain, right? Now the formula for the conversion of time domain to frequency domain, or you can say the formula for the Fourier transform is given by y omega is equals to minus infinite to infinite y of t into e raised to power j omega minus of j omega t dt. So in this, if I put omega is equals to 0, right? If omega is equals to 0, so y of 0 will become minus infinite to infinite y of t dt. So this is what I told you. So integration of minus infinite to infinite of any function dt is equals to y naught. Y naught, y of 0, sorry. Y of 0 means the value of this y function in frequency domain at 0, right? So from this property, I can easily find out y of 0, that will be equal to x1 of 0 multiplied by x2 of 0. So x1 of 0 is what? So x1 is this function. When I put omega is equal to 0, so sampling function looks like this. It is decreasing in amplitude, right? At 1, at 0, its value is this peak value, whatever. If it is just like that, so its value will become 1. But here I have a magnitude of 3, so its value will become 3 itself, right? So x1 of 0 will become 3. So this is 3, and similarly we can find out in this we put omega is equals to 0, so that will become 1 plus 2 plus 2. So this will come out to be 15. So 15 will be our correct option. So this is how we solve this type of question. So there in this question nowhere written that you have to solve or you have to transform the signal or xyz. You have to use your own brain that how to crack this type of question. So this is the easiest way to crack this type of question. Whenever you see the convolution, you just go into frequency domain. That's the best way to solve the convolution problems, right? Moving on to the next question. So next question says that find out the Fourier transform of x of omega of a Fourier transform x of omega of xt is equals to e raised to power minus t square. So this is a standard function which is known as Gaussian function. As you can see, Gaussian function is equal to e raised to power minus a of t square, and its Fourier transform is this. So we can use this type of function. So e raised to power minus a t square, which is Gaussian function, in its Fourier transform will be under root pi by a e raised to power minus omega square by 4a. Here we have a function this. So in this a is equals to 1. So just put a is equals to 1. So our function will become under root pi e raised to power minus omega square by 4. That's it. So that will be the Fourier transform. So option C will be the correct option. So this type, if you know the standard transformation, then this will become easy question for you. If you don't know, of course, you will struggle to find out this Fourier transform, and eventually you will not even get it, right? So best way is to just learn the standard transformations, and this is a recent year question from GATE 2023 only. So yeah, it's they can ask you direct things, so you have to remember this. So all the transform are all about the basic transforms which you remember and the properties. That's all you have to remember in the transforms. Be it a Laplace transform, be it Fourier series, be it Fourier transform, be it Z transforms, any type of transforms. Next question. So here question seems to be very big, but this particular thing is just theory about Fourier series only. Let's just read it. The exponential Fourier series representation of a continuous time periodic signal xt is defined as, so this is the formula given of Fourier series conversion of a continuous time periodic signal x of t, right? So this is exponential Fourier series expansion. So where omega naught is fundamental angular frequency, xt is the of fundamental frequency of xt, coefficient is ak, and the following information about xt and ak is given. So this is nothing but, you can say, little of explanation of the formula of Fourier series only. So question is not that big, question is just that. Okay, there is nothing in the question. Question is just that. So now, the information given is first, xt is real and even, having fundamental time period of 6. The average value of xt is equals to 2. ak, which is the coefficient of the series, is equals to k, where from 1 to 1 less than equal to k, less than equal to 3, and 0 otherwise. So you have to find out the average power of the signal xt. Let's just see that what does this information means. So first thing saying that, first thing you just write is that a fundamental time period is given as 6. That's it, right? And it is also saying that, so I can say that fundamental time period is given as 6, and it is also saying that xt is real and even. Real and even means, so Fourier series coefficient can be real and even, real and odd. So there are different properties related to that. So if I am saying that they are real and even, that simply means that AK is equals to A of minus K. That is the only meaning of real and even. So if I say, expand a Fourier series, so A naught is the average value, A1, AN, and goes up to AK. Similarly, in negative also, A minus n goes up to AK. So that basically means real and even means, so these two values are same. Similarly, these two values are same, and so on. So that is the meaning of real and even. Second, so second saying that average value of xt. So as I have told you, average value is this. This is A naught is average value. So you can say that A naught value is given to us, that will be equal to 2. Third, AK coefficients are defined here. So AK value is K for this value of AK. So I can write that A of 1 will be equal to K value. So that will be 1. Since they are real and even, so A of minus 1 will be also equal to 1. A of 2 will be equal to K value, that is 2. A of minus 2 will be also equal to 2. Similarly, A of 3 is equals to 3, and A of minus 3 will be also equal to 3. So this is how I can define these values. And after when k is greater than 3, its value is 0. So only six components we have, six coefficients we have. Now, what they are asking in the question, so this was given to us. So we are still dealing with that part which is given to us. The question is saying that we have to find out the average power of the signal xt. So whenever it comes to the power calculation, you always follow the Parsivals theorem. Right? Parsivals theorem. Right. So what does Parsivals theorem say that whenever we want to calculate the power, so this is the power formula dt, and if I say that in if this is the power in time domain and in frequency domain, but here we are talking about the Fourier series. So Parsivals theorem says that summation from n is equals to minus infinite to infinite ak square. That's easy. So ak value we know. So power will be, I can expand it like a of minus 3 whole square plus a of minus 2 whole square plus a of minus 1 whole square plus a naught whole square plus a1 whole square plus a2 whole square plus a3 whole square. So these are the all coefficient. That's it. All the coefficient values we know. Just put them up. And since I can make it at least little more easier because I know these and these are same. This and this is same, and this and this is also same. So I can say that 2 of a1 square plus 2 of a2 square plus 2 of a3 square plus a naught whole square. So I know the values: 1 square, 2 of 2 square plus 2 of 3 square plus 2 of square. So if you solve this, you will get power is equals to 32. So that is your, which is your correct option? Option number D will be your correct option. So this is the best way to solve this type of question. Right. See you in the next class.